Okay, so there was one Johnston proved that, just a minute, R square to check my board is not working properly. Yeah, now it's working. R square is the squared simple correlation between y and y hat. Multiple R square they are giving. However, you need to prove this R square is a simple correlation between y and the estimated value of y, where y hat is equal to x okay. So could you do this thing? Do I need to cover this in the class, or you could complete this? You know, all of you could do this, or there is some issue, there is some problem in understanding this problem? Rudra, could you do this?
No, ma'am.
Shreya?
No, ma'am.
Aditya?
No, ma'am.
Thank you. So is there anyone who could try and could proceed so that, you know, we may understand, yes, we can go forward with this kind of thing? Anyone? Ritaja?
No, ma'am, I couldn't do it.
Okay, so, you know, so let me. Actually, there are very few problems where you have to apply your knowledge and try to do these things, you know. So we do not have, you know, just like +2 level kind of thing, so many books with so many exercises. So it's not possible. So try your best. Otherwise, you will have only lesser options to try. Okay, so please note down, without loss of generality, we can use the deviation form of the regression model. Okay, so without any loss of generality, suppose originally the model was y is equal to, say, alpha plus beta x plus u, and I am writing the model in terms of deviation form. This I am telling you. This kind of thing, okay? This is also will be ui because u bar is equal to 0. So this format we are considering, deviation form we are considering. Okay. So next, the simple R square between y and y hat. I'm considering the simple R square between y and y hat. This can be presented as y prime y hat square divided by y prime y into y hat prime y hat. So what I am doing, Pearson's product moment simple correlation is, in the numerator we will have covariance term, and in the denominator we will have two standard error terms. Okay. Now I am considering square of the correlation. So in the numerator, I'm considering the square of covariance. So I'm considering the relation between y prime, y and y hat. I'm considering the relation between y and y hat. Okay. So there is y and there is y hat. All y and y hat are of order n cross 1. N cross 1. Okay. So if I consider y prime y hat, that means I am considering summation yi square. I am considering summation yi square in the numerator. Okay. So I'm considering this kind of thing, covariance between y prime and y hat, and since I'm considering r square, I'm considering square of this. In the denominator, we will have the two variance term, y prime y is the variance of y, and y hat prime y hat, that is capturing the variance of y hat. Okay. So once I write the definition in this format, in the numerator, y prime I am keeping as it is, and in place of y hat, please put this value, x prime x inverse, x prime y. Okay, and we are taking square of this, denominator y prime y as it is. In place of y hat, again we will consider this one. Now if I consider transpose of this, because it is y hat transpose y hat. Okay, so if I consider transpose of this, would anyone tell me what will be the expression? What I'll write as transpose of y hat? Anyone? Please be fast, you know. If you are slow, you are...
Y prime, x prime.
Slowly. Y prime, x prime, x prime.
X prime, yes, ma'am. Oh, no, ma'am, no. Y prime x inverse, x prime x inverse, x prime.
X prime, very good. And then I'll write y hat. So x okay, is it okay? So if I do this, I'll be able to make an adjustment between this x prime x and x prime x inverse. Okay, so numerator I'm keeping as it is. Denominator y prime y I am keeping as it is. And here is it okay to everybody? Now, if you look at the numerator is y prime x prime x inverse, x prime y. So the second term in the denominator is identical to the term we have in the numerator. So this is equal to okay. Now, are you getting any expression from the numerator? Are you understanding what it is? Can we write the thing as transpose of this? So anyone, numerator, what is x prime x inverse x prime y?
That is beta hat prime.
Beta hat prime. Now, what is the numerator now? Beta hat prime x prime y?
Yes.
Yes. And what is the denominator?
Yes.
Yes. So what is this? So if I start with the formula of simple correlation between y and y hat, we are reaching at r square. So r square is simple correlation between the observed value and the estimated value. Okay, so this is another definition of r square. So goodness of fit is simple correlation between the observed value and the estimated values, y and y hat. Okay, so with this, I think we have covered the things we planned from Johnston. Okay, so anyone has any problem with any particular problem from Johnston?
Yes, ma'am. Question number 3.9, that matrix beta hat equals to 1, 1, and -2.
Just a minute. Just a minute, let me open the book. Yeah, 3.9, yes. What is your 3.9?
And that matrix hypothesis 1, 1, and -2.
Okay, 1, 1, -2. Yes, which we did in the last class.
No,
Yeah.
I'm not understanding the formula you used for F.
For which test, beta 1 is equal to 1. For this, we
No, the last test, that matrix 1, 1, simultaneously testing.
Okay, 1, 1, -2.
Yes, ma'am.
Anyone else? Would you please help him? This is complete, I hope. So, can I erase this one? So last day, for the last formula, we used, the deviation of beta hat, etc. Anyone will help us? Let me check. It was 3.9, no? I think this formula you are telling.
Yes, ma'am. I'm asking, can I calculate RRSS and URSS differently?
Yes, you can proceed in that way too. We use this formula too when we have, this kind of simultaneous testing, kind of thing. Therefore, I mentioned it is not that you will be not able to calculate URSS, RRSS. Yes, you can. You can. And in that case, I think you are getting F value to be 72.22.
Yes, ma'am.
Yeah.
Can I calculate using the formula that 1, 1 and -2 and the x prime x inverse and that 1, 1 and -2?
Yeah. So here what I did, I am considering beta hat square x prime x in the numerator.
Ma'am?
Yeah.
Ma'am, we will have a k-1 element in denominator, isn't it?
K minus?
K-1.
Yeah. Yes. Yeah. So it's not that you will be not able to use the usual formula for F test. So you can proceed with RRSS minus URSS divided by number of restrictions formula too. No problem. Okay, if you are comfortable with that, you can go with this. And this is an alternative specification where we are considering beta hat square x prime x, so that part. And since we have values for all the coefficients, we have values for all the coefficients. So I am considering ESS kind of thing in the numerator. So this is another alternative. So if you are comfortable, no problem. If you
will I use the formula beta prime hat x prime y or beta prime hat x prime x beta hat?
আরেকবার বলো।
If I calculate differently RRSS, should I use the formula beta prime hat x inverse x?
Yeah, you can do anyway. Yes, when you are using the formula F is equal to RRSS minus URSS divided by number of restrictions divided by URSS divided by degrees of freedom. There is no problem, if you calculate ESS using the other formula, no problem in that. You can derive your formula for RSS using the standard formula. So you can use for ESS, you can use beta hat prime x prime y formula, or this kind of formula, beta hat x prime x beta hat, which is indicating the other one, beta hat square x prime x. Okay, so you can go for any of the two, no problem.
Thank you.
With the usual F test, no problem. For the third variety, go with the usual F test. If you are comfortable with that, go with that, no problem. You go with this, no problem.
Okay, thank you, ma'am.
তাহলে Johnston complete?
Ma'am, I have a doubt in 3.1.
Yes. 3.1, which one?
Ma'am, 3.12.
3.12.
And there is no value given, like no numerical value is given in that sum. So how will we test the thing?
এটা তো থিওরি লিখতে বলেছে। Consider a multiple regression model for which all classical assumptions hold, but in which there is no constant term. Suppose you wish to test the null hypothesis that there is no relationship between y and x, that is h naught colon beta to beta k against the alternative, at least one of the betas is non-zero. Present the appropriate test statistics. So please go through the question properly.
Okay, ma'am. Then only the theoretical thing, the concept we have to explain, right?
Yeah, definitely. Okay, and state its distribution with relevant degrees of freedom. So yesterday I mentioned that already all these things are covered. It's not that always you have to go with the numericals. Similarly, with 3.18, you have to find out, yes, the partial R square can be presented as T square by T square plus degrees of freedom. So theoretical proof you need to present. It's not that you have to do this numerically, and the question is not like that, isn't it?
Yes, ma'am.
Okay. Any other question from Johnston?
Ma'am, 3.10.
3.10.
Ma'am, একটু hint দেবেন?
তোমার ভ্যালুস গুলো যেখানে রয়েছে summation y is equal to 20.
হ্যাঁ ম্যাম।
Okay, so 10 sets of observations are there. So n is equal to 10, summation y, summation x1, summation x2, summation y square, summation x1 square, x2 square, etc. All these things are given. Estimate the regression of y on x1, x2, including the intercept term, and test the hypothesis that the coefficient of x2 is equal to 0. So তুমি ওই coefficients গুলো derive করেছো?
হ্যাঁ ম্যাম।
So no problem with the first part, because you can use the matrix algebra or you can write the normal equations and you can solve for the values of the parameters. So first you can consider the deviation form if you like, And then you can derive the parameters. So either you can use matrix algebra, that is, you can derive beta hat is equal to x prime x inverse x prime y. Or what you could do, we can write the equation as okay, so we can write the x prime x matrix here, corresponding beta hat columns will be there, and x prime y values will be there, and we can generate 3 equations, and so simultaneously solving the equations, we can also derive the values for beta hat. So do you want to know what will be the values for the coefficients, or, you know, because already you solved this thing? তুমি কি চাইছো বলো তো?
ম্যাম আমি চেষ্টা করবো আপনার ফর্মুলাটা।
হ্যাঁ, অর্কদীপ আরেকবার বলো।
ম্যাম আমি ট্রাই করবো তারপরে, এরপরে আমি ট্রাই করে নেবো বাড়িতে।
ও আচ্ছা আচ্ছা, বুঝতে পেরেছি। So you can do either way. সবাইকেই বলছি, when these kind of problems are there, you can go with this kind of matrix algebra, the way we solved one numerical exercise in the class, or what we can do, we can create equations. You know, you will get, suppose, a 3/3 x prime x, and then you can have beta, suppose, all these things. And here also you will get the matching, you know, column order. So in this case, maybe you will get, here there is one intercept term. So better first to convert everything in the deviation form and find out the values of the coefficients, and then find out the value of the intercept term. Okay. So anyone completed this exercise so that we can check the values, you know, whether you got the right values or not? কেউ করেছো?
Yes, ma'am.
কি ভ্যালুস বের হচ্ছে?
ম্যাম কোনটা কিসে?
বিটা হাট গুলো?
Beta hat -13, 1 and 3.
-13, 1 and 3. Very good. These will be the values. বাকি যারা করেছো বা কমপ্লিট করোনি, this is -13 and 1, 3. So these are the values. আর ওখানে ছিল যে test the hypothesis that the coefficient of x2 is equal to 0. Okay. So coefficient of x2 is equal to 0. For that, you need to run the test. Now you need to look at the information whether you will be able to find out the t statistic, or you have to go it with you have to solve it using F1. You know, it depends on what is the information you have. If you have information more on ANOVA table, that is ESS, RSS, TSS kind of thing, if you can use F1. Or, you know, if you can calculate the SU square for beta 2 hat, actually variance of beta 2 hat, in that case, you can use the t statistic as well. So if you can calculate variance of beta 2 hat, you go with the t statistic. If you are more comfortable with the ANOVA statistics here, you can go even with F1. Both the things are same. T is equivalent to F1. T square is equivalent to F1. So you can solve it using F1. You can solve it using T, whatever you like. So once you get these values for beta hat, etc., you need to find out the value of RSS. Once you get the value of RSS, you will be able to find out SU square, and then you calculate variance covariance matrix of beta hat. The diagonals will give you the variances. So from the diagonal elements, we can choose the variance of beta 2 hat, and using that you can frame your T statistic. Is there anyone who solved the things in this way, derived the T statistic?
T is 2.5.
2.5, yes, T is 2.5. সবাইকে একটু চেষ্টা করতে হবে, আমার মনে হচ্ছে অনেকের ট্রাই করাটাই এখনো হয়ে উঠছে না, okay, because we did all these things, earlier also we did this thing, and yesterday also we solved for this thing. What you need to do, you have to solve for several exercises, otherwise you will be never comfortable with this kind of things. So the formula is with you and the data you have, and now you have to do the exercises, solve several matrix equations, etc. You will be able to get the values. So are you comfortable with this thing so that I can move for Madala? Anyone else? Any other question from Johnstone?
From 3.7C.
3.7C. Who told this? 3.7C.
Me, Shreya.
Shreya, yesterday I mentioned 3.7C. We don't need to solve.
Okay, ma'am.
We need A and B. Okay. So everything we don't need to do, Chebyshev's inequality or everything we don't need to do. At least if we are comfortable with the assumptions, estimations, and hypothesis testing, then it will work. So I'm, now I'll move for Madala's book and discuss several numerical and theoretical exercises from Madala. So everyone has the book, and open the chapter on multiple regression or k-variable regression. So it will be 192. So everybody has Madala's book, if we look at question number 1, all the questions are based on definitions. So define the following terms: standard error of the regression. Now, what is the meaning of standard error of the regression? Ajay? What is the meaning of standard error of the regression?
The RSS divided by n minus k.
Anyone else? মানে আমাকে যদি বলা হয় যে we have to define the standard error of the regression, so what will be the thing which will come in our mind? Upali? Anyone apart from Rudra? মানে তোমরা এটা কি জানোই না, না বলবে না, না কি বলো তো, এরকম করে কি করে ক্লাস হবে? You have to try, Yes, Shubhangi? Okay, so try all these definitions since you are not interested in interacting. So look at the definitions. Everything is done in the class. A, B, C, D, only the nested and non-nested hypothesis, this you can leave. Okay, and H also will be in the periphery of our syllabus. So A to H apart from G, that is covered in the class. Second problem, in a multiple regression equation, show how you can obtain the partial R squares given the T ratios for the different coefficients. So this is also done in the class. We checked that partial R square, that is equal to T square by T square plus degrees of freedom. Okay, so partial R square is related to the T ratios in that sense. So you have to present the proof for this question. The next is in the multiple regression equation, y is equal to alpha plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus u. Explain how we will test the joint hypothesis beta 1 is equal to beta 2 and beta 3 is equal to 1. Okay, so this is the question, So multiple joint hypothesis, beta 1 is equal to beta 2 and beta 3 is equal to 1. So I hope we discussed this kind of context where we have the multiple specifications. Okay, in this section, we talked about all these varieties, So, if you look at C and D, multiple hypotheses we are considering, beta 1 plus beta 2 plus beta 3 is equal to 0 and beta 2 is equal to beta 3. And in case 4, beta 1 plus beta 2 plus beta 3 is equal to 1 and beta 2 is equal to 2 beta 3. So C and D belong to the variety where we presented how we can test multiple hypotheses at a time. So follow this method. Here the things are more or less similar. Here the two hypotheses are beta 1 minus beta 2 is equal to 0, which is stated as beta 1 is equal to beta 2, and the third one is beta 3 is equal to 1. Okay, so follow the steps which we did in cases of C and D, and I hope you will be able to explain how we can solve this joint hypothesis. So next I'm moving for 4. The following regression equation is estimated as a production function, a very common production function. So if you look at the book, it is the Cobb-Douglas production function. Actually, it is the linear version or log linear version of the Cobb-Douglas production function. So I'm writing it in the board. Log Q is equal to 1.37 plus 0.632 log K plus 0.452 log L. R square is equal to 0.98. And standard errors are in parentheses. Standard error means square root of variance of regression coefficients. So this is the structure of the data, and it is also mentioned that covariance BK-BL. BK and BL are the estimated values of beta L and beta K. This is minus 0.044 and sample size is 40. Test the hypothesis at 5% level of significance. Okay, so alpha, that is level of significance, is 0.05. The first test is there are CRS, constant returns to scale. So this is the problem. So I hope first of all you are understanding this is the log linear version of the Cobb-Douglas production function. Cobb-Douglas production function that is given by Q is equal to A L to the power, say, beta 2. Suppose this is the expression, and then I am making it log linear. Log Q is equal to log A plus beta 2 log L plus beta 3 log K. So we are making the thing like this. So I hope you are understanding that. Now, any idea how we will proceed for part A? BK is equal to BL. You need to test BK is equal to BL, which is equivalent to, actually your null hypothesis is H naught colon BK minus BL is equal to 0. Last day we did this kind of test. Beta 1 plus beta 2 plus beta 3 is equal to something. So here BK minus BL is equal to 0. So can we use a T statistic here?
Yes, ma'am.
So I'm getting the answer, yes, we can. So Oritra, would you tell me what will be the nature of the T statistic, how we will present it?
Yes, ma'am. T statistics is beta 1 hat minus beta 2 hat by standard error of beta 1 hat minus beta 2 hat.
Very good. And in the standard error of beta 1 hat minus beta 2 hat, how we will proceed?
Variance of beta 1 hat plus minus variance of beta 2 hat.
Not minus. Variance is always come with the plus sign, and it is like
Oh, okay, ma'am.
B whole square formula. A square plus B square minus 2AB.
Oh, okay, ma'am. So minus 2 covariance of beta 1
Yeah.
and beta 2, and then beta 2 and beta 1.
And all the information is given, data is given, so you will be able to write down the thing. Very good, Aditya. So what we have to do, we need to write the relevant T statistic. So as he mentioned, we will write, in the numerator, we have to write, actual coefficients are B, and we are using the estimated values, So I'm writing it as, change. And in the denominator, as he mentioned, we have to consider standard error. Okay. So numerator, already the values are there, 0.632, 0.452. This is So this is the thing. So the variance values are, you will get the variance values from the parenthesis. The standard errors are there. So we will take square of these terms, square of these terms to get the values of the variances, and the covariance value is also given. So once we plug all these values, we will be able to find out the actual value of the t statistic, and then we need to compare it with the tabular value. Now, which tabular value we will consider? As I mentioned, if nothing is mentioned clearly in the alternative specification, we generally consider the right-tailed test. So if I consider the right-tailed test, the tabular value, we will consider T 0.05. And then what will be the degrees of freedom here?
40 minus 3.
40 minus 3, yes, 37. Okay. And if this calculated t-value is greater than 3, in that case, directly you will reject the null hypothesis. If this calculated t-value is less than 1, then directly you can accept the null hypothesis. If the calculated t-value lies in between 1 and 3, then only you compare with the tabular value. So if it is less than 1, you accept H0, greater than 3, you reject H0. However, if the value is in between, in that case, you need to compare it with the tabular value. Okay, so this is the idea. Anyone could complete this thing by this time. What will be the value of this t statistic? Anyone, any doubt, any question? Is it okay? কারোর সলভ করা হয়েছে? So please check, complete this thing. Now, what about the B part? How we will test for CRS, or what we will do if I need to test for CRS? Any idea?
BK plus BL equals to 1.
Okay, so he is telling BK plus BL is equal to 1. Is it right, or we need to, change the hypothesis a bit? So what is your idea? Twinkle, what's your idea? And Ujan, would you like to add something, or we will go for BK plus BL is equal to 1? Anyone else? Shraya, Titir? I hope you can remember the idea of CRS, constant returns to scale. I don't know what is the problem with all of you in interacting that way and then sending a mail. What will be the pile of questions, So yes, Rudra is absolutely right. The CRS means, the sum of the coefficients beta 2 plus beta 3. If you look at the Cobb-Douglas production function, CRS means beta 2 plus beta 3 is equal to 1. Okay, so yes, the hypothesis will be, to test CRS, our hypothesis will be BK plus BL is equal to 1. Now, if BK plus BL is equal to 1, we will follow the similar methodology to test the hypothesis. T we will define in terms of beta hat K plus beta hat L minus 1. And in the denominator, we will write the standard error of beta hat K plus beta hat L. Okay, so in this case, so let me write the thing here. So T we will consider since 1 is a constant, you may write minus 1 or you can simply write this value. Okay, in both the cases, you have to present the same value. So numerator will be like this and the denominator will be square root of variance of beta hat K, B hat K plus variance of B hat L plus 2 of B hat K, B hat L. So proceed in this way. So you will be able to derive the value for T statistic, and then if required, compare it with the tabular value, you will get the result. Next, we are moving for problem number 5. Problem number 5 is a true-false type question. So indicate whether each of the following statement is true, false, or uncertain, and give brief explanation or proof, this kind of thing. Okay. So apart from small numerical exercises in your internal assessment exam, many a times you will get this kind of questions. A statement will be there and you need to assess the statement. If required, you need to add a very small proof for this. So this kind of question you may expect. So here the question is, suppose that the coefficient of variable, suppose that the coefficient of a variable in a regression equation is significantly different from 0 at 20% level. Generally, we do not consider 20% level of rejection. However, they are considering that. So it is significant at 20% level. If we drop the variable from regression, both R square and R bar square will necessarily decrease. The most important part is, if we drop this coefficient from the regression model, both R square and R bar square will necessarily decrease. So is it true, false, uncertain? Okay, so that is the thing. So your idea? So anyone, please try to explain what will happen.
Ma'am, decrease.
Both R square and R bar square. Clearly give the answer. Okay, what you expect? There are two elements, R square and R bar square. So what you want to say? Yes, Nazma.
Ma'am, will we have to check from the hypothesis or R square formula and R bar square formula?
Where is the hypothesis? I didn't understand your, what you wanted to mean or indicate. Would you please tell me what you what you are trying to understand or what you are trying to say? Yes, Nazma?
Ma'am, R square is 1 minus RSS by TSS,
Mm-hmm.
and there R bar square is
Simply R
1.
square is ESS by TSS, you know.
Yes, ma'am.
It is ESS by TSS, so yes.
And there R bar square is 1 minus RSS by degree of freedom by TSS by n minus 1.
Yeah, that these are the right, these are the formula for R square and R bar square.
Yes, ma'am.
Is we are dropping a particular explanatory variables, necessarily both R square and R bar square will decline. So what will be your argument for this particular question? Your formula for R square and R bar square is absolutely fine. So what will be your argument? What do you think? তিতির চক্রবর্তী?
ম্যাম আর স্কোয়ার কমবে, বাট আর বার স্কোয়ার কমবে না হয়তো, কারণ ওটা তো লস আর গেইন দুটোকেই অ্যাকাউন্ট করছে, তো ডিএফটাও কমে যাবে না।
Yes, so that will be your argument, you know. So whenever we will drop any regression coefficient or we will drop any explanatory variable from our model, R square will necessarily decline because R square formula is ESS by TSS, so R square will definitely decline. However, for R bar square, you have to mention the proof, you know, if the mod T value or T square or F that is greater than 1 or greater than equal to 1, in that case, if we drop that explanatory variable from the model, the explanatory power of the model will fall and R bar square will fall. However, if it is less than 1, dropping the variable R bar square will increase. So for R bar square, it is not necessary that whenever we will drop a particular explanatory variable from the model, R bar square will fall. R bar square may fall, R bar square may increase. It will depend on the fact that whether the mod T, T square or F that is greater than equal to 1 or it is less than 1. Okay, so you need to add these explanation here and you have to write finally whether what you are thinking about this statement. Next is compared with the unconstrained regression, estimation of a least squares regression under a constraint, say beta 2 is equal to beta 3, will result in higher R square if the constraint is true and the lower R square if it is false. So there are two regression equations, unconstrained regression equation and constrained regression equation. Constraint is given by beta 2 is equal to beta 3, and the argument is regression under constraint will result in higher R square if the constraint is true and lower R square if it is false. So next, what will be your argument for this question? So this time, Ritaja, will you try?
Ma'am, I'm reading the question.
Okay, please. Compared with the unconstrained regression, estimation of a least square regression under a constraint will result in higher R square if the constraint is true and the lower R square if it is false. So Ritaja, could you complete reading the question?
Yes, ma'am.
So what is your idea?
Ma'am, the unconstrained model has greater goodness of fit. So R square will be high than the
Yes.
restricted model. So if the constant is true, there will be higher R square. And if it is false, then it is lower R square.
So is this part okay? If it is true, in that case higher R squared. If it is false, in that case lower R squared. Is this part okay?
I think so.
No. Okay, no, never. So try to understand the thing very well. It doesn't matter whether the constant is true, constant is false. Whenever you will drop one regression coefficient from your model, which means you are dropping one explanatory variable from your model, in that case there will be some reduction in R square, because R square is equal to ESS by TSS. Whenever, if the constant is true, then also, if the constant is false, then also, if you drop any regression coefficient from the model, or if you drop any explanatory variable from the model, R square will necessarily decline. All these issues related to significant, insignificant, these are related to R bar square. For R bar square, if the coefficient gives you the t statistic greater than equal to 1, in that case you have to retain it. Less than 1, you have to drop it, because dropping, in that case your R bar square will improve. So all these issues, if the coefficient is insignificant, then dropping R bar square will improve. These are coming with adjusted R square. R square cannot capture these issues. The coefficient may be significant, the coefficient may be insignificant. Whenever you are dropping anything, R square will necessarily fall. For R bar square, the judgmental issues will come in terms of hypothesis testing, etc. Okay, is it understandable? Should I proceed, or I need to repeat anything? So the next one is, in least square regression of y on x, least square regression of y on x, observations for which x is far from its mean will have more effect on the estimated slope than the observations for which x is close to its mean value. So this is the idea. In a least square regression of y on x, observations for which x is far from its mean will have more effect on the estimated slope than observations for which x is close to its mean value. So what will be a line of thinking here? We are talking about two types of x. Some of the x's are very close to the mean value x bar, and some of the x are very far from the mean value x bar. And it is stated that in a least square regression of y on x, the usual model, yi is equal to alpha plus beta xi plus ui kind of model, observations for which x is far from its mean value, deviating much from its mean value, will have more effect on the estimated slope than the observations for which x is close to its mean value. For this question, our line of thinking will come in terms of variance of beta hat. The estimated value is beta hat. Now the question is, on these value, which kind of x will impart more effect? xi is far from mean or xi is close to its mean value. So there are two types of xis here. The question is, which xis will put more impact on beta hat? To answer to this question, we will consider variance of beta hat. Now, in a simple regression equation, what is the value of variance of beta hat?
Sigma square divided by summation xi square.
Sigma square divided by summation. And this, when we are using the matrix algebra, we are writing sigma square x prime x inverse, this kind of thing, you know. So variance of beta hat is equal to sigma square divided by summation xi minus x bar whole square. So what we are finding, this xi minus x bar whole square is in the denominator of variance of beta hat. Now tell me, if xi's are far from its mean value, in that case variance of beta hat will be lesser, or if xi's are close to its mean value, in that case variance of beta hat will be lesser. So remember that there is an inverse relation between the variance of xi and variance of beta hat. Actually, the denominator you can write in this way also you may plan. Okay, you may plan the denominator in this way too. So, you know, if I rewrite the definition in this way, variance of beta hat is inversely related to variance of xi, and variance of xi will increase if xi's are so what will happen if variance of xi increases? In that case, variance of beta hat will fall, and our objective is to minimize the variance, okay, because we want to find out best linear unbiased estimators. This means we need to minimize the variance, okay. So, you know, if xi's are far from mean, in that case variance of xi will increase, and that in turn will reduce the variance of beta hat. So xi's which are far from its mean value will have more effect on beta hat. More effect on beta hat means it will reduce the variability of beta hat when we will move from one sample to other. Okay, so sampling fluctuations of beta hat will be reduced if variance of beta hat is minimized. Okay, so if xi's are far from its mean value, in that case variance of beta hat will be lesser, and therefore it will have more impact on estimated regression coefficients compared to the situation when xi's are very close to its mean value. Any query, any question? Or you are understanding it perfectly? Is it okay to all of you?
Yes, ma'am.
Next, we are moving to question number 6. Question number 6 is the following estimated equation was obtained by ordinary least square regression 1960 to 1979 inclusive. So there are 80 observations and there is an estimated regression model. yi hat is equal to 2.20 plus 0.104 x1 t plus 3.48 x2 t plus 0.34 x3t, and standard errors are in parentheses. The ESS is 112.5 and RSS is 19.5. Which of the slope coefficients are significantly different from 0 at 5% level? Calculate R square, calculate R bar square. So easy sum. Question number 6. Everyone is comfortable with question number 6, or do I need to explain any part of question number 6, how to proceed for A, B, C? Is it clear to everyone? Is there anyone who has problem with question number 6? Or Kodeep?
Yes, ma'am.
Is it okay?
Hi, ma'am.
ঠিক আছে. So we are moving for question number 7. Suppose that you are given two sets of sample with the following information, sample 1 and sample 2. Sample 1, n is equal to 20, x bar 20, y bar 25, sx6. That means summation xi square or summation xi minus x bar whole square, 80. Summation xi minus x bar into yi minus y bar, that is 120. Syy, that is 200. And the similar information, similar kind of information we have on sample 2. So estimate a linear regression equation for each of the samples separately and for the pooled sample. So forget about the pooled sample. At this moment, you don't need to do it for the pooled sample. So I hope all of you, given this database, all of you will be able to estimate the regression coefficients both for sample 1 and sample 2. Okay, the next was state the assumption under which the estimation of pooled regression is valid. Now, in context of pooled regression model, that is in context of Chow test, we learned about two assumptions. The variances across the sample that will be equal and contemporaneous covariance that will be equal to 0. So two assumptions we discussed. Now, among these, we need to verify only the first assumption here. Because regarding the second assumption, we don't need to prove anything. For the first assumption, we need to check whether the variance coming out of the first sample is equal to the variance which is coming out of the second sample. However, at this moment, it may be difficult, so I'm leaving this part. So I'm not discussing the numerical exercises based on Chow test. For the Chow test, there will be only the theory part. Theoretical, statistics which we have discussed in the class. So later we will discuss this problem. Move to problem number 8. A researcher tried two specifications of the regression model, alpha y is equal to alpha plus beta x plus u, and y is equal to alpha prime plus beta prime x plus gamma prime z plus u prime. Explain under what circumstances the following will be true. Beta hat is equal to beta hat prime. So there are two regression models. And okay, so explain under what circumstances we can have that is the coefficient values associated with x will be similar. Okay, so anyone? Under what circumstances beta hat will be equal to beta hat prime? Your answer may be under no circumstance it will be possible. Okay, either the answer will be under this situation it is possible, or your answer will be it is impossible. So what do you think? Choyan? Choyan?
Yes, ma'am.
Yeah, any idea?
Ma'am, I'm trying, ma'am. Give me some time.
Okay. Anyone, if you have any clue in between, please tell me. Answer is based on the ethics of multiple regression. There is nothing to find out here. So Choyan, would you like to add?
No, ma'am.
So what do you think? Is it possible? Just tell me that thing. Lesser variables mean, we are considering ceteris paribus. As you are incorporating lesser variable in the model, that means, other things remaining constant. You are trying to measure the impact of a particular x on y. Other things remaining constant, you want to like the measure of change in price on demand. And then in the second case, along with the price, you are bringing income in your equation and re-estimating the effect of price on demand. So what do you think? In both the cases, the value or the coefficient suggesting dq by dp will be similar or it will vary?
ম্যাম সিমিলার হবে না?
সিমিলার হবে মনে হচ্ছে, কেন বলো তো?
কারণ ম্যাম যদি বিটা ক্যাপের সাথে বিটা ক্যাপ ড্যাশটা চেঞ্জ করে যায় তাহলে তো রিগ্রেশনটাই চেঞ্জ হয়ে যাবে।
রিগ্রেশনটা চেঞ্জ হয়ে যাচ্ছে, তুমি বলছো রিগ্রেশনটা চেঞ্জ হয়ে গেলেও ভ্যালুস গুলো সেম হবে, তাই তো? রিগ্রেশনটা তো চেঞ্জ করে যাচ্ছেই, একটাই শুধু প্রাইস নেওয়া হয়েছে, একটা প্রাইস অ্যান্ড ইনকাম নেওয়া হয়েছে। কোয়েশ্চেনটা হচ্ছে আন্ডার হোয়াট সার্কামস্টান্সেস ওই রিগ্রেশন কোএফিসিয়েন্ট which is indicating the change in quantity demanded with respect to change in price that will remain same. Regression is changing or the equations are changing. হ্যাঁ চয়ন বলো তো কেন মনে হচ্ছে একই থাকবে?
কারণ ম্যাম যদি আমি একটা নতুন ভেরিয়েবল ইন্ট্রোডিউস করি তাহলে তার ইম্প্যাক্টটার জন্য তো বিটা ক্যাপটা চেঞ্জ না করলেও মানে চলবে।
না করলেও চলবে? তাহলে তো দেখো, we should not go for a multiple regression analysis or should not go for any analysis where we will incorporate more explanatory variables. So if ceteris paribus gives us the similar thing, as we consider in the earlier case, in that case, what is the need for using a multiple regression model? Okay, or what is the need for incorporating more explanatory variables in the model, both in terms of economics or in terms of econometrics? If we think on this issue, when I'm considering only x, I'm limiting the model, and in that case, directly we are getting impact of change in price on quantity. However, in reality, the actual impact of change in price on quantity demanded is adjusted or affected by so many things. That is, if my taste and preference is something, different from you, in that case, interrelation between quantity demanded and price will vary. If gender changes, in that case, it may vary. If income changes, that may vary, So whenever we are considering more explanatory variables in the model, all these beta hat will work as the partial correlation coefficient. That is, given rest of the explanatory variables, what additional thing will be explained by these particular x? Whenever we are considering a two variable analysis, there is no difference between the multiple R square, partial R square, and simple R square. Now, simple R square is telling what is the correlation between y and x. However, when we are moving to the multivariate analysis or multiple regression model, k-variable regression model, the very essence of the entire structure is all the beta coefficients are now related to the partial correlation coefficients, not with the simple correlation coefficients. So all the beta will be conditioned on rest of the explanatory variables. So there will be no situation or no circumstance under which beta hat will be equal to beta hat prime. Now again, if you incorporate one more explanatory variable, the same beta will change a bit. Again, another explanatory variable, the beta will change a bit because, in the first case, there is no conditional thing. You are considering a simple relation between y and x. Then you are making a condition, given income, what is the impact of price on quantity demanded? Then, given income and prices of the related goods, what is the impact of own price on quantity demanded, and so on. So everyone getting the clue how you need to proceed for this kind of question? Joyon, now you are getting the clue?
Yes, ma'am.
So look at theory things, how the ideas have changed when we moved from two variable or the simple model to the model where we are considering all the explanatory variables. Remember that now your regression coefficients are decided or explained by the partial correlations, and partial correlation is the conditional relation between y and a particular x given the rest. Okay, so naturally the coefficient value will change, so there will be no circumstance when you will have beta hat is equal to beta hat prime. So next I'm moving for B. If uy hat and uy hat prime are the estimated residuals from the two equations, then summation uy hat square will be greater than equal to summation ui hat prime square. So next is B. Okay, so these are the estimated sum of squares of the residual. Okay, so these are all RSS values. So what will be our line of thinking here? Can we define one model as the restricted model and the other model as unrestricted model?
Yes, ma'am, we can.
Yeah, so which one will be the restricted model and which one unrestricted? Yes, please proceed.
First equation will be restricted model.
The first equation will be the restricted model. Very good.
And second one will be unrestricted.
Definitely. Okay. So ui hat prime, this is URSS and this is RRSS. So can we have a situation when RRSS is greater than equal to URSS?
Yes, ma'am.
So please, tell us, give us some clue why you are telling yes.
Because first equation will have lesser explanatory and greater residual.
Yeah, yeah.
And second one will be greater explanatory and lesser residual.
Yeah, yeah. So if we can define the first model as the restricted model and the second one as the unrestricted model, it will happen that generally it is the possibility that RRSS will be greater than URSS. Okay, so but in fact, under most of the circumstances, we will have strict inequality. RRSS is greater than URSS. Okay, so definitely we can, if we consider the weak inequality, we can state the position in this way. RRSS is greater than equal to URSS. She is absolutely right. C. C is beta hat is statistically significant at 5% level, but beta hat prime is not. Beta hat is significant level, but is it possible? Beta hat is significant at 5% level of significance. That means, X can explain Y. And beta hat prime is not, that means X cannot explain Y. So if in the first model we get X can explain Y, is it possible that in the second model we will get X cannot explain Y?
No, ma'am.
Why?
Ma'am, like in the first model, maybe it can explain a bit more, but it cannot be like it become insignificant in the second model.
Anyone else? Any other idea? Yes, Titir is giving some justification. Anyone else? Any other idea? Shreya, would you like to add something?
No, ma'am.
Anyone else? Rudra?
Ma'am, here beta prime includes the fact that we are it is a partial correlation coefficient. So there can be a possibility that beta prime is insignificant. Not sure.
Why do you think so?
Beta prime is a partial correlation coefficient. So
yes,
partial regression coefficient. So
yes. Beta hat prime is a regression coefficient which is based on partial correlation coefficient. Yes. Then
if if y can x means if the gamma can explain the what the
so I am helping you. If X and Z are highly correlated, that is if there is multicollinearity. Okay. So if there is multicollinearity, that is if X and Z are highly correlated, given Z, X has nothing new to explain about the variation in Y. So in that case, there is a possibility that though in the earlier model, when only X was there, X could explain Y. However, if X and Z are correlated or if there is multicollinearity in the regression model, in that case, given Z, X will have nothing new to explain regarding the variation in yi, and in that case, beta hat prime will not be significant. Okay, so there is a possibility, or under what circumstances means if there is multicollinearity in the second equation, or if X and Z are linearly related to each other, in that case, it is possible that in the first model, beta is significant. However, in the second model, beta prime is insignificant. So everybody? So now Titir?
Yes, ma'am, got it.
Okay. The final one is beta hat prime is statistically significant at 5% level, but beta hat is not. That is the reverse one. The reverse one. Beta hat prime is significant at 5% level, but beta hat is not. Is it possible under any circumstances? So Titi, now what do you think?
No, ma'am, I don't think it's possible now because
Yeah,
there is no
now
other.
your answer is right. It's not possible. The other one was possible because of presence of multicollinearity. We can justify the argument. However, in this case, it is an impossibility. Okay, under no circumstances, it is possible that beta hat prime is significant. However, beta hat is not significant. Okay. So, please write down everything properly after the class so that look at the questions once again and please prepare your write-ups so that your argument becomes clear. So next, question number 9. There is a regression model after using 26 observations. You are getting an estimated model. Here, T ratios itself are in parentheses, and you have the value for R square. The same model was estimated with the restriction beta 1 is equal to beta 2. And the estimates they are giving. So test the significance of the restriction beta 1 is equal to beta 2. State the assumptions under which the test is valid. Then suppose x2t is dropped from the equation. Should r bar square rise or fall? Would r square rise or fall if x2t is dropped? So all these questions are there. So, numerical values are there, r square values are there. So I hope you will be able to answer to all the questions, And regarding r square, r bar square, you need to look at the value of the t statistic. If mod t is greater than 1, greater than equal to 1, your suggestion will be something. If mod t is less than 1, your suggestion will be something regarding r bar square. Regarding r square, whenever there will be a reduction in number of explanatory variables, r square will definitely fall. So I hope you will be able to do it. Question number 10. That is also, we did the same thing from Johnstone. Suppose that the least square regression of y on x1, x2 to xk yield coefficient bj, okay, none of which exceed their respective standard errors. However, the f ratio for which the equation rejects at the 5% level, at the 0.05 level, the hypothesis that b1 is equal to b2 is equal to bk is equal to 0. Is it possible? No, the question is a bit different from Johnstone. So it is telling that suppose that the least square regressors y on all k explanatory variables yield coefficient estimates bj, none of which exceed their respective standard errors. So coefficient values are not exceeding their standard error means the t statistic is very small. Okay, because t is beta hat divided by standard error. So if the numerator is smaller compared to the denominator, that means t values are very small. So t values are very small. However, when we are considering the overall significance of the model, if statistic is very high, so the question is it possible? What do you think is the reason for
Yes,
this?
ma'am, এটা তো multicollinearity-টা।
এটা multicollinearity, absolutely right. So you will be able to answer to this. And 11, again, you have true false type things. So try all these things on your own. 12, then coming to question number 12, this kind of question you did from Johnstone. There are values on r square, r bar square, simple r square, partial r square, and you need to justify whether the results are possible or not. So do up to question number 12 for your internal assessment, okay? So Madala, up to question number 12, you complete for your internal assessment. So, the questions you got from Johnston, questions you are solving from Madala, so, I hope by this time you are understanding what can be the pattern of the question, etc. So the question will be based on the theoretical issues we covered. The questions will be based on the type of numerical solutions we covered in the class. Okay. And there will be no long question. All the questions will be, short questions. You don't need to write more than half pages for most of the questions. It will be the small things. Anyone, any query, any question, anything? Because, next week you have the exam, and before that we will not have any theory class.
Ma'am, yesterday there was a question in which the null hypothesis was beta